The cube is being increased in size such that the length of each edge is increasing at 0.1 centimeters per second. Find the rate at which the surface area and the volume of the cube is increasing when the side length is 10 centimeters. So let's just think about the cube. So let's call the side length L, and the surface area we'll say is S, and the volume we'll say is V. We're given that dl dt is equal to 0.1. That's the rate of change of an edge. The surface area for a cube, each face, remember, is going to be L squared, and there's 6 of them, is 6L squared. And the volume is L cubed. In this first part, we're required to find ds dt, and in the second part, we're required to find dv dt. So let's look at the surface area. S is equal to 6L squared, so ds dl is 12L. We want to find ds dt, and we can form a chain for this. And that chain is ds dl dl dt. Notice how if you cancel the dl's, now I know these aren't fractions, you get ds dt on this side. So ds dl is 12L, and dl dt is 0.1. So this is 1.2L. So ds dt, given that L is equal to 10, is 1.2 times 10, which is 12. And remember, that would be in square centimeters per second. We do exactly the same sort of thing for the volume. Volume is L cubed. So dv dl is 3L squared. And then dv dt, which is what we want, sorry, that's dv dl. dv dt is going to be dv dl multiplied by dl dt, which is 3L squared times 0.1, which is 0.3 L squared. So dv dt, given that L is equal to 10, is 0.3 times 100, which is 30 cubic centimeters per second.